Assalamualaikum warahmatullahi wabarakatuh. So this time around, it will be on cross section perpendicular to the y-axis for Washer method. So let f and g here be continuous functions on the interval c to d, and suppose that fy is greater than or equal to gy for all y on c to d. This should be y, sorry, for all y on the interval c to d. So let R be the region that enclosed by x equal to fy, x equal to gy, and the lines y equal to c and y equal to d. So therefore, the volume for the solid of revolution that obtained by revolving the region about the y-axis is V equal to integrate c to d pi fy squared minus ty squared with respect to y. Okay, for example, as we can see in this figure, this region bounded R is rotated at the y-axis. Okay, so it will be looking like this. Okay, so here we would like to find the inner radius and outer radius. This is the axis of rotation. So from the axis of rotation to the nearest equation function would be the inner radius. And from the axis of rotation to the farthest border of the region bounded would be the outer radius here. Okay, since R is horizontal, so V would be equal to integrate pi something, integrate respect to y. Therefore, this one should be the value of y1 and here would be y2. And the functions here should be in terms of y. In terms of y. Okay, let's look at the other figure here. Okay, let's say we have this kind of figure. That means this is x equal to fy and here x equal to gy. The image for the rotation would be looking like this. Okay, as you can see, this would be the inner circle and this is the outer circle. Okay, when we find the, let's say, the area for the outer circle minus the area for the inner circle, we can find the area for the region bounded. Okay, that means why we integrate, because we want to find the summation of all the circles inside the region bounded. Okay, let's look at the example. So this one, let's say we want to determine the volume of the solid form when the region R here in the diagram below is rotated about the line x equal to 0. Okay, when stated here line x equal to 0, by right we rotate at the y-axis because y-axis is line x equal to 0. Okay, so here from the axis of rotation to the nearest border of the region bounded would be the inner radius, and from the axis of rotation to the farthest region bounded, the border of the region bounded, this would be the outer radius. It will be similar even you drag it from here. This will be the inner and this is the outer. Okay, that will be the same. Okay, next, this is since our R is horizontal, by right you know that V is equal to pi integrate something must be with respect to y. Okay, here should be the value of y1 and here is y2. Okay, as you can see, it starts from y equal to 0 and here the other intersection point is at y equal to 3. That's why here, as you can see, the V is equal to pi integrate from 0 to 3. Okay, next, outer radius. This is the curve, which is the outer radius. That's why we have R out squared is equal to 4y minus y squared, which is this expansion. And the inner radius is actually y equal to x, which means if we want to let x as a subject, it will be the same, x equal to y. Therefore, we have y squared, which is y squared. Okay, and here would be outer radius squared minus the inner radius squared. Okay, simplifying, we will have this term and then integrate. After integrate, substitute the value of upper boundary minus the substitution of the lower boundary. You can also write it as like this to make it much clearer why we get 0. Okay, and the answer would be 108 over 5 pi or 21.65 unit cube. Okay, the next one. Determine the volume of this solid form when the region R in the diagram here is rotated about the line x equal to y. Okay, the first thing we want to know, where is the line x equal to y, right? So, what I would suggest you to do first is to find the intersection point here. Okay, okay, when we find the intersection points here, we have y squared equal to y plus 2. Okay, why this become y plus 2, remember? Sorry. All of this should be in terms of y, so x will be the subject. So we have x equal to y plus 2. Therefore, we have y equal to negative 1 and y equal to 2. This is negative 1 and here is y equal to 2. When we substitute, okay, y equal to 2, we have here x equal to 4. Okay, that's where we know where should we draw the line x equal to 5. Okay, the line x equal to 5, let's draw the line. Okay, okay, here is my ruler. Sorry. Okay, let's say the line y equal to 5 is here. We use another color of pen. Let's say red. Okay, done. So, we will rotate this graph here at x equal to 5. Okay. Next, we want to determine whether we will integrate with respect to y or x, right? That's when we find the intersection point. Drag from the line of rotation to the nearest border of region bounded, that will be your inner radius. Drag from the line of rotation to the farthest border of region bounded, that will be your outer radius. Okay, since R is horizontal, which means here we will integrate with respect to y. Okay, we have y1 and y2 from here, the intersection point, negative 1 to 2. And right now, we need to determine what is the inner radius and what is the outer radius. Okay, let's look at the inner radius first. Okay, we want to find the distance from here to here, which means we want to find the distance from here, from the line y equal to x equal to y plus 2 to the line x equal to 5. Okay, if you have something vertical, let's say we want to find the distance vertically, what we will do? Let's say this one is x equal to 7 and this one x equal to 1. So, the distance between these two lines would be 7 minus 1. That means right minus left. Okay, that's why we will take the left, which is the axis of the line of rotation, minus the graph here. Okay, the function here, which means we have 5 minus y plus 2. Remember, it should be written in bracket because minus. Okay, therefore, inner radius is 5 minus 2 is 3. So, 3 minus y. The outer radius would be the distance between the line of rotation with the curve here. Okay, right minus left. Therefore, 5 r out is equal to 5 minus the curve, which is y squared. Okay, we have the outer radius as 5 minus y squared. Okay, as you can see here, the outer radius r out squared is equal to 5 minus y squared. Okay, expand it outside the integral so that your integral would be less complicated. Okay, you have here the outer radius squared and the inner radius squared, r in squared, is equal to 5 minus y plus 2, as I've written here, where we have 3 minus y squared. This is the expansion of the factor. Okay, and here v is equal to pi, integrate from negative 1 to 2. Remember, this should be the value of y. Okay, and here is r out squared minus d r in squared. Okay, simplify. Okay, simplify. The step is the same. Okay, simplify, integrate, and then substitute value. Okay, substitute the value of upper boundary minus the substitution of the lower boundary, and hence we have v equal to 153 over 5 pi or 30.6 pi unit cube. Okay, that's all for Washer method. Thank you. Assalamualaikum.